Chapter 8 is getting into polynomials, and we'll explain what polynomials are. We got a few things for this section. We need to find out how to add and subtract polynomials, and to do that we have to identify some different things about polynomials. So the first place we're going to start at is, what is a monomial? And a monomial is, I want you to write this stuff down, a real number, a variable, or a product of the two that have whole number exponents. Okay, so some examples of that. Just the number 18 by itself is a monomial. Just a variable like z by itself is a monomial. A variable divided by a number is a monomial. A number with a variable and an exponent is a monomial. And a number times a couple of variables is a monomial. So monomials can look very different depending on a number of things, but they can have numbers and variables that are multiplied by each other. That's what you have to kind of focus on. Each monomial then has a degree. Okay, and the degree is found by taking the sum of the exponents of its variables. That right there. The degree of a non-zero constant is 0. Okay, so we're going to focus on, we're going to look at each one of these. Okay, so what would be the degree of 18? Well, that is a non-zero constant, and so therefore, since it doesn't have any exponents on variables, the degree is 0. Z, technically z is z to the first, so that has a degree of 1. Negative 4x squared, we're looking at all the variables exponents, so that's 2. That's the degree of that one. 2.5x y to the third is 4. There's 3 here plus a 1. Remember, it says the sum of. And then lastly, a divided by 3, the degree is 1, because this a has a 1 right there. So, pause the video, take a minute, and find out the degree of each one of these. Hopefully for 5x, you said 1, because this x has a 1 there. For 6x cubed times y squared, we would add up the 3 and the 2, so that gives us a degree of 5. And the 4 has no variables or exponents, so therefore it is 0. Adding and subtracting monomials. So when you have monomials and you want to add or subtract them, you have to make sure that they have like terms. And meaning these variables with their exponents have to be the same. I almost think of them as a label, like the label is x squared. So I have 5x squareds right here. Okay? It could be the same, like if we're dealing with money, 5 quarters. This is 3 quarters. So if the labels are the same, if the exponents and the variables are the same, you can add the real numbers that are in front. So 3x squared plus 5x squared becomes 8x squared. Here, we have x cubed times y, and here we have x cubed times y. So since they're the same, we can combine the coefficients out front, which is 4 minus 1. There's a 1 right here. So that's 3x to the third y. Okay. Here, what's the sum? Negative 6 plus 11, that becomes 5x to the fourth. The difference here, you can subtract them. So this is x squared y fourth. X squared y fourth, we can combine them. 2 minus 7 is negative 5x squared y to the fourth. Now, a polynomial is taking one or more monomials and adding them together. So a polynomial is a monomial or a sum of monomials. And here are examples of what a polynomial could be. It could be just a single term, like this, or this, or this. Or if we combine all of these, or some of them, such as we're doing all of them down here, we are combining all of those, and that now together becomes a polynomial. Now each one has its own degree, okay, which we're going to talk about in a second. But when we write these, we want to make sure to write them in standard form, which means that we write them when the degrees of the monomial terms decrease from left to right. So as you see here, we have 4, then 2, then 1, then 0. They decrease. If these are ever out of order, what we want to do is just kind of reorder them so that the highest is on the left and it goes down. If you ever have a tie, it doesn't matter which one goes first. Okay. The degree of a polynomial. So the degree is the same as the degree of the monomial with the greatest exponent. So which monomial has the highest exponent in here? Well, it's x to the 4th. And so the degree of the polynomial is 4. Okay. Now, depending on the degrees of the polynomial and the number of terms, we give them names. So here we have this polynomial has a degree of 0, this one has a degree of 1, this one has a degree of 2 because there's a 2 right there. This one, the biggest exponent is 3. This one, the biggest exponent is 4. Okay, so those are the degrees, and based off of those, when the degree is 0, we call it a constant because it has no variable. When the degree is 1, it's a linear. So that's, and think about that. That's the same as y equals 5x plus 9. That's slope-intercept form. Or yeah. And so it's just like the basic form for a line. Here, a degree of 2 is a quadratic, a degree of 3 is a cubic, and anything more than that, we just really say it as, like a 4th degree polynomial. Then, depending on how many terms there are, so how many terms, this one has 1 monomial, this one has 2 monomials right there and right there, this one has 3, this one only has 1, and this one has 3 again. So if they have 1 term, it's called a monomial, which we talked about. 2 terms is a binomial. 3 is a trinomial. Back to 1 monomial and back to 3 trinomial. Now any of these can be mixed and matched together. So you could have a linear trinomial, you could have a cubic monomial, and so on. And that's how you name these things. All right, so write each polynomial in standard form. So we want the exponents to be from high to low. So this is 4x squared plus 3x. The degree is 2, because that's the highest exponent. And the number of terms is 2 as well. So based off this chart, a degree of 2 is a quadratic, and with 2 terms is a binomial. So this is a quadratic binomial. This one, the x's can combine, the 4x and the 7x. So we have 11x minus 1 plus 5x to the third. I want to put these from least to greatest, so I'm going to go 5x to the third plus 11x minus 1. My degree is 3. My number of terms is also 3. So based off that, 3 is a cubic, and 3 terms is a trinomial. So I have a cubic trinomial. And that's where we're going to leave you with this. You can get into some other, more difficult ones. There are examples in the book if you want to look at these. But again, this would just be combining polynomials. So remember, you have to look for like terms. X cubes go together, x squareds go together, x's stay together, and constants stay together.